Hello students, this is AMOL INGOLE, and in this video I'm going to explain numerical on Viterbi decoding. This is the numerical which we are going to discuss in this video. Two generator sequences are given and it is asked to draw the encoder diagram, construct a trellis diagram and decode the received code word using Viterbi algorithm. If you look at the statement, you can easily identify the number of output bits or number of outputs. It is n is equal to 2 in this case. Number of memory units required, that is m, and that is also equal to 2 in this case. The encoder diagram can be easily drawn using the generator sequences, and this is the encoder diagram. You can see the earlier video, and you will come to know how this is drawn. Now, to construct a trellis diagram, you will first need to construct a response table. You can again watch the earlier video for response table. This is the response table for this numerical. Using this generator sequence, you can easily draw the diagram, and from diagram you can easily construct this response table. The trellis diagram for this numerical is this one. You can see the video on trellis diagram and you will understand how this trellis diagram is drawn. Let's have a look at the steps of Viterbi algorithm, which we discussed in earlier video. First step is divide the given received sequence in packets of n bits and write those packets over the trellis diagram. The second step is finding the Hamming distance between the n-bit packet and the output of the encoder, and then finding the path metric by adding the Hamming distance of earlier branch. Third step is discarding the path with higher path metric. Fourth step is repeating step 2 and 3 for the paths with lower path metric till the last time step. And the fifth step is select the path with the lowest path metric and decode the code. We're going to follow these 5 steps in Viterbi decoding. So let's start. This is the received code word given in the numerical. So the first step is dividing this received sequence into packets of n bits and writing those packets over the trellis, over this trellis like this. So this is the same received code which is written in the form of 2 bits packet. So this is first 2 bit, next 2 bit, like this. Now let's see the step 2. Step 2 is finding the Hamming distance and writing the path metric. So here the Hamming distance between the packet of the received code word, first packet in the first time, that is 1 1 and 0 0. Here the Hamming distance will be 2, and that 2 can be written as a path metric for this path and will be written in a box like this here at this node. The path metric for this path can be found by finding the Hamming distance between 1 1 and this 1 1. As there is no difference, the Hamming distance is 0, and the path metric for this path will be written in box like this, which is 0. So 0 is the path metric for this path. Let's repeat the same step in time step number 2. Here 0 1, finding the Hamming distance between 0 1 and this 0 0. There are 4 paths, so we are finding it for the first path. Hamming distance is 1 here, as there are two, there is only one place at which it differs. So this is 1, this is 0. So Hamming distance is 1 here, which will be added with the path metric of earlier branch. So this is 2 plus Hamming distance between these two, that is 1, and will be equal to 3 here. Next is finding Hamming distance between 0, 1 and 1, 1. Hamming distance is 1 here, and 1 will be added with this 2, and the total path metric will be 3 for this path, for this entire path. Next, Hamming distance 0, 1 and 0, 1 between these two, as both are same, Hamming distance is 0 and will be added, this Hamming distance will be added with the earlier, which is again 0. So the total path metric for this path will be 0 in this case. And the last path which is left in this time step 2 is this one. Here this is again 0, 1 and this is 1, 0. Hamming distance will be 2, which will be added with the earlier path metric, which is 0. So 0 plus this 2 will be 2 here. Okay. Now the third step is discarding a path with higher path metric. So if you compare, out of this 4, there are 2 paths. This one, which has got path metric 3. This is path from here to here, and the other path is from here to here, which has got path metric 3, which is higher in value compared to this 0 and 2. So this 2 will be discarded. This one and this one will be discarded and can be shown like this. By showing a cross on those paths, you can show that these 2 paths are discarded. Now look at this. When you discard this path, look at this node. There are 2 branches which are leaving from this node. If you discard this path, which is the only path coming at this node, then these 2 will have no meaning. So you can show that these 2 paths are discarded as well. Similarly, look at this node. There's only one branch coming at this node, and there are 2 leaving from this node. If you discard the incoming branch, the outgoing branch should also be discarded and will be shown by a cross over it. So you discarded here 4 branches. Whatever branches are survived now, this one and this one. Let's repeat step 2 and 3 for time step number 3 here. So again, finding the Hamming distance between the survived path and 0, 1. So this is the survived path here, which is not yet discarded. So 1, 1 and 0, 1. Hamming distance is 1. Again, that Hamming distance will be added with the previous one. So that is 0. So this 1 plus 0, which is equal to 1. So this is the path metric for this path now, from here to here. For this entire path, the path metric is 1 here. Okay. The next one is finding path metric between this 0, 0 and 0, 1, this dotted path. So Hamming distance is 1 here, which will be added with the earlier path metric, which is 0. So the Hamming total path metric will be 1, and it is the path metric for this entire path. Next, this is the 4th one, right? It is the path metric for this path. 1, 0 and 0, 1 Hamming distance will be 2, which will be added with this 2, 2 plus 2, 4. So the Hamming path metric will be 4. It is this path from here to here. This is that path which has got the path metric equal to 4. Next, Hamming distance between 0, 1 and this 0, 0, 1. As they are same, the Hamming distance will be 0, which will be added with the path metric 2. So the total path metric will be 2 for this path from here to here, like this. Now again, Step 3, which says that you have to discard path with higher path metric. So if you compare, this is path metric 4, which looks much higher than 1 and this 2. So you can discard this 4 and this 2. These two paths can be discarded. Like this. You can discard this fourth one, and you can also discard these two, because if you look at this node, there are two branches incoming. One is already discarded, and we have discarded this now. So these two will have no meaning, so should also be discarded. Similarly, this will be discarded. Why? Because this value, this path metric is higher than this one and this one. So we have discarded this 4. We have discarded this 2 now. Okay. If you discard this, you can see at this node, this one and this one got discarded. So the outgoing branch should also be shown as discarded, right? By trying to cross over it. Okay. Now let's find the Hamming distance for time step number 4 here. Okay. So this is now 0 1 and this is 0 0. Hamming distance will be 1 1 plus the earlier path metric. Look at this. This path was discarded, but this path was not discarded. So the Hamming distance of this should be added with this one. So this 1 plus this 1. Total path metric is 2 here. So, and that path will be from here to here, like this. Okay. Then the next one is 0 1 and this is 1 1. This is the path which is not yet discarded. So this is the Hamming distance between these two will be 1 here, 1 plus earlier 1. So you can write that path metric here as 2 here in the box. Okay. Next one is this pink colored one. Hamming distance between 0 1 and this 0 1, as both are same, Hamming distance is 0, which will be added with the earlier one. Earlier is this path, right? And no, not this one, sorry. This is 1, earlier path metric 1, and this 1 plus 0 will be 1 here. You can write it like this. Next is 0 1 and 1 0. Hamming distance will be 2. That 2 will be added with the earlier path metric, and that is 1 here. Right? You should not take this 4. Why? Because it is already discarded. Okay. Let's write that Hamming distance as 3 here. Right? This 2 plus 1, that is 3. Okay. Now the next step is to discard the path metric. Now here, if you see, there are two paths with path metric 2, one with path metric 1, and the remaining one has got path metric 3. So here you can do like this. You can discard only this path and proceed with these 3 paths, this 3 path metric, and you can take the discarding decision at the final step, at the final time step. Okay, that can also be done. Or you can also discard this 2 and this 3 here and proceed with only one path. That can also be done. So let's discard this 3, right? When you discard this 3, these 2 will also get discarded, and you can show it like this. Okay. Now let's find the path metric. We'll proceed with these 3 path metric now in the final step. Path metric, the Hamming distance between these two will be 0. 0 will be added with the previous path metric, which is 2. So the total path metric is 2 here. The next 0 0 and this 1 1 path Hamming distance will be 2. 2 plus this 2, 4. 4 is the path metric for this path now. Next, 0, 0 and 1, 1. Hamming distance is 2. Will be added with this one. Total path metric is 3. It is for this path now. Next, 0, 0 and this dotted line 0, 0. Hamming distance will be 0 as there is no difference. Plus 1. Total path metric will be 1. Then 0, 0 and 0, 1. This pink colored one. Hamming distance between these two will be 1. 1 plus the earlier one is 2. So total path metric is 3 here. Next, 0, 0 and 1, 0. Hamming distance is 1. And that 1 will be added with the earlier path metric. And the total path metric will be 3 here. Okay. Now, if you see all these path metrics, you have to take a decision. That is step number 5. You have to select a path which has got lowest path metric. See here, there is only one which has got path metric 1, and all others have path metric more than 1. So you can discard all these paths having path metric more than 1 like this. So I have discarded all the other, leaving only this path having path metric 1. And if you follow that path from this node, you find that this is the only path left. This is the only path left. And we got this path using Viterbi algorithm. Now what you have to do with this path now? Look at this. You have to focus on these outputs here. You have to focus on these outputs of these corresponding branches. What you have to do now? This was the received code word given. We followed Viterbi decoding algorithm, and we came to know that this is more likely path which we have got. So you have to note down these outputs. These outputs are nothing but the corrected path, right? Which will correct the received code word, and will also find out. Now see here, this is the decoded or the corrected one, right? If you compare the received one and the bits taken from this path, like 1, 1, this is 0, 1, this is 0, 0, this is 0, 1. In each time step you have to write that, and this is 0, 0. You will find that the received code word and the decoded one differs here, right? In this packet, exactly at this bit, 6th bit, it's differing. So this is where the error occurred, and we could detect that error. Detect that error using Viterbi decoding algorithm. Right? This is how you can follow the steps and find out the path. Okay, you can show that path. You can show that trace by using some zigzag line over this path. Right? Thank you.